Welcome, everyone. Today we're going to bridge a gap that has existed for decades in the industrial world. We often hear about maintenance as a cost center, but the truth is that reliability is a financial engine. In this session, titled Reliability Speaks Finance, we will explore how maintenance excellence directly creates EBITDA, optimizes cash flow, and drives enterprise value. Let's start with a foundational thesis for the executive suite. Maintenance doesn't just consume cash. It controls the volatility of how that cash is generated. For a board of directors, the question shouldn't be how much did we spend on repairs, but rather how much enterprise risk did we retire and what value did we protect. Think of reliability as the operating system that converts your physical assets into predictable earnings. Why is this conversation so critical right now? Because our profession is undergoing a massive shift from simple maintenance excellence to value assurance. Leading organizations like SMRP and Deloitte are highlighting that while 90% of companies see digital transformation as essential, less than half are using their data effectively. The board is no longer looking for activity. They are looking for measurable financial outcomes and resilience. Our journey today follows a clear storyline designed to build a bridge from wrench work to enterprise value. We will start by reframing how we talk about maintenance, move into quantifying value levers and governing risk, and finally look at how to scale these efforts using data and AI to report effectively to the board. The core of our challenge is a translation problem. When maintenance speaks, it often describes symptoms like the pump failed. But what the finance department hears is revenue is at risk. Our job as leaders is not to simplify the technical work, but to translate it accurately into the language of the balance sheet. A high backlog isn't just a list of jobs. It is a deferred liability that could impact future performance. In part one, we focus on reframing the conversation. It's time to stop defending maintenance spend as an unfortunate necessity and start explaining it as a tool for earnings protection and risk retirement. The old way of looking at maintenance is far too narrow. If we only look at maintenance cost in the ledger, we miss the big picture. You can easily cut your maintenance budget by 10% this year, but in doing so, you might destroy 10 times that value through downtime, quality losses, and safety exposure. Lower spend is simply not the same as lower total cost. What does the board actually buy when they approve your budget? They aren't buying work orders or vibration analysis reports. They are buying predictable outcomes. They are investing in process stability and production certainty, which are the fundamental drivers of cash generation. Every reliability story you tell should land in one of these four buckets. If your initiative doesn't protect EBITDA, improve free cash flow, reduce enterprise risk, or enhance enterprise value, it probably isn't ready for executive approval. These are the four levers that matter at the highest levels of the organization. Think of reliability like an iceberg. The visible part is the maintenance budget, what we spend on parts and labor. But the hidden, much larger mass beneath the surface is the avoided volatility. This includes the massive costs of downtime, energy waste, and safety incidents that reliability efforts prevent every single day. Reliability has a seat at every row of the income statement. Beyond just the expense line, it impacts revenue through better availability, COGS through labor efficiency and energy savings, and gross margin through improved yield and quality. It's a total performance multiplier. On the balance sheet, maintenance decisions shape your assets and liabilities. Carrying too many spares traps cash in inventory, while carrying too few creates stock-out risks. Similarly, deferred work isn't just waiting to be done. It is effectively maintenance debt that represents a real liability for the company. When it comes to cash flow, the key word is controllability. Planned reliability work represents controlled cash flow. Unplanned failures, however, lead to uncontrolled cash drain through premium labor, expedited freight, and emergency rentals. Reliability is our best tool for keeping cash flow predictable. Now in part two, we will build the reliability value tree. This is our framework for connecting every single maintenance decision to those high-level financial outcomes we just discussed. The value tree shows us that the financial impact of reliability isn't just one number, it's a portfolio. By improving availability, yield, energy efficiency, and asset life. We provide the inputs that drive EBITDA and free cash flow, ultimately increasing the overall value of the enterprise. Our first EBITDA lever is revenue protection. If your plant is running at capacity and demand is high, every hour of uptime has a direct margin value. A reliability leader should be able to say, "This pump repair isn't just a task. It's protecting $X of contribution margin for this quarter." The second EBITDA lever is intelligent cost removal. The goal isn't less maintenance, it's less waste. When we eliminate defects, we permanently remove the need for expensive emergency labor and rework. Cost reduction is only durable when we ensure that the underlying risk hasn't increased. Reliability also impacts yield, quality, and energy. An asset that isn't performing optimally rarely just stops. It usually starts bleeding value long before it fails. This degradation leads to quality variations, scrap, and higher energy intensity, all of which erode your margins quietly. Moving to cash flow, we look at responsible CapEx deferral. Extending the life of an asset creates value only if the risk is quantified. Spending $2 million on a targeted overhaul to defer a $20 million replacement is brilliant capital management, but only if you have the risk controls in place to prevent a catastrophic surprise. Inventory optimization is a delicate trade-off between working capital and risk. We shouldn't ask why we have a part, but rather what financial exposure that part controls. A slow-moving spare isn't necessarily dead money if its absence would result in a multi-million-dollar stockout event. Outage discipline is another critical cash lever. Shutdowns are moments of concentrated cash exposure. By managing scope creep, material readiness, and startup quality, we ensure that these outages protect our assets without leaking excessive cash through inefficiency or rework. Ultimately, we are driving enterprise value. The market rewards predictable cash flows and penalizes unmanaged risk. A plant with unstable assets carries a valuation haircut because investors see uncertainty in earnings quality and future capital requirements. To communicate this to the board, we need a standard cost of failure equation. A failure is not just a repair bill, it's a cascade. We must account for loss margin, quality loss, energy waste, and even customer impact to see the true economic consequence of an event. Let's look at a board-ready calculation for just 1 hour of downtime. By using site-specific rates for contribution margin, repair costs, and startup waste, we can show that a single hour of failure might actually cost the business $66,000, which is far more than the simple repair labor might suggest. We also have to consider the full cost stack. The financial impact of downtime often expands non-linearly over time. The second hour is often more expensive than the first as expedite fees, customer penalties, and compliance risks begin to stack up. This brings us to the role of the financial translator. The most successful reliability leaders can discuss a failed seal with the engineering team using technical precision, and then turn around and explain the capital request to the CFO using clear business logic. In Part 3, we dive into decision economics. Getting board approval depends on showing disciplined choices based on NPV, criticality, and asset health. We need to move from technical metrics like MTBF to monetary risk. Vibration scores are great for engineers, but the board wants to know how much annualized risk exposure we have today and how much of that risk we will retire by making an investment. Asset criticality isn't just about how expensive a machine is. It's about how much financial exposure it controls. A critical asset is one that poses a disproportionate risk to the enterprise's ability to meet its safety, environmental, and production goals. Consider this example. A $35,000 repair might seem small, but it could justify a $300,000 reliability program if that program retires $440,000 in annualized risk exposure. The logic for investment is based on risk reduction, not just the cost of the fix. We must also identify our bad actors through an economic lens. A bad actor isn't necessarily what fails most often. It's the asset causing the highest value leakage across the entire system, including labor, quality, and management distraction. PM optimization is about finding the economic sweet spot. Under-maintaining leads to failure risk, but over-maintaining creates waste and can actually induce failures. We aim for the lowest total risk-adjusted cost, not just 100% compliance for compliance's sake. When choosing whether to repair or replace, we use NPV thinking. A replacement might look expensive up front, but when you price in the saved downtime, lower energy use, and reduced risk over 5 years, the high capex option often becomes the most financially sound decision. Redundancy is never free. It adds capital cost and maintenance complexity. The board's decision here is essentially choosing the right price for production certainty, whether that's through installed spares, portable backups, or accepting a certain level of outage tolerance. Think of an outage as a financial instrument. We are essentially trading a short-term loss in production for a long-term reduction in risk. The most successful outage is the one that retires the most risk at the most efficient cost. Just as software developers deal with technical debt, we deal with maintenance debt. Deferring work might help this month's cash flow, but it creates a hidden liability that increases future volatility and silently eats away at enterprise value. Part 4 addresses governance and metrics. We need a system that finance can audit, leadership can govern, and the plans can actually execute. A board-level dashboard shouldn't just show activity. It should answer, are we safer? Are we more reliable? And are we more cash efficient? It should highlight the financial impact of risk retired and the value to spend ratio of our programs. We need to focus on leading indicators that predict financial results. Lagging indicators tell us where we've already failed. Leading indicators like critical PM compliance and schedule health tell us if our risk controls are actually working before a miss hits the EBITDA line. It's important to remember the KPI hierarchy. Every metric has its specific audience. Craft-level metrics drive daily execution, while executive-level metrics should focus on business value and risk governance. A reliability risk register is where asset health becomes managed business exposure. It connects specific equipment risks to money, an owner, and a deadline, ensuring that technical issues don't remain mere anecdotes. For larger organizations, Reliability Value Assurance Office can bridge the gap between engineering, finance, and operations. This isn't about adding bureaucracy. It's about protecting the quality of our decisions and ensuring that savings are real and verifiable. Reliability is a team sport. Success requires an ownership triangle where operations, maintenance, and finance all work toward a shared target of risk-adjusted production certainty rather than optimizing their silos separately. We also need a decision cadence that matches the speed of risk. Daily controls and weekly schedules keep the plant running, while monthly value reviews and quarterly board updates ensure our long-term strategy remains on track. When it comes to budgeting, we should defend maintenance spend like a risk investment portfolio. Every major dollar should be mapped to how it protects EBITDA, reduces energy waste, or manages a specific asset risk. A board-ready business case should be rigorous. It must avoid hope or fear, and instead focus on clear assumptions, quantified financial exposure, and a verified audit trail for the value created. Prioritization is key. A plant doesn't need an unlimited budget. It needs a ranked list of risk-return decisions. Using portfolio logic ensures we fund the projects that offer the highest confidence and the greatest risk retirement. We must be careful with avoided costs. To be credible, these claims need a baseline, a clear counterfactual, and sign-off from finance. This ensures the organization trusts the value we claim to be protecting. Finally, everything must be auditable. We must distinguish between one-time savings and ongoing run rate value, and between realized cash and theoretical risk reduction. If the value can't be traced, it shouldn't be claimed. In Part 5, we look at digital, data, and AI economics. Technology is a tool, not a solution in itself. It only creates value when it changes how we work and make decisions. It's important to remember that AI is not ROI. A predictive alert has zero value if it doesn't change a decision or lead to a completed work order. We must judge digital investments by how they shorten the time from a signal to a financial result. The industry's signal is clear. Digital transformation is now baseline. Research shows that 90% of manufacturers see it as essential, But the real challenge remains using the data effectively. We are moving from the era of collecting data to the era of augmenting operations with AI. Data quality is financial quality. If our asset hierarchy and failure codes are messy, our business cases will be weak and our AI results will be untrustworthy. Finance-grade insights require finance-grade data integrity. Predictive maintenance has huge potential, reducing downtime by up to 50%. However, the board will always ask, can our organization actually execute the workflow? Accuracy in prediction is meaningless without discipline in execution. The missing link in many tech programs is the alert to cash flow path. An alarm is just noise unless there's an owner, a spare part, and a scheduled window to act on it. Value is only verified when the work is complete. Even with advanced AI, human judgment remains accountable. We must be clear about decision rights. Who can stop production based on an AI alert? How do we handle overrides? In safety-critical environments, accountability must be explicit. Scaling technology requires maturity. A successful pilot proves it can work. Enterprise scale proves your management system does work. To move across sites, you need standard taxonomies and repeatable playbooks. We must also recognize that cyber resilience is now part of reliability finance. If your digital infrastructure is compromised, you lose visibility and control. Protecting our OT networks is essential for production continuity and cash flow protection. When investing in technology, the board should ask, what decision will this change? Every investment should pass a value path test, identifying exactly which financial exposure it reduces and who owns the adoption of a new workflow. We conclude with Part 6, the Executive Playbook. This is how you turn these concepts into a 90-day leadership system that produces results. Our 90-day playbook is simple. Start with a baseline, move to build investable cases, and then launch a formal governance cadence. This moves the organization from slogans to finance-grade reliability management. In the first 30 days, build your baseline. Identify your top value leaks, your critical assets, and your maintenance debt. Create a finance-approved model for what downtime actually costs, so everyone is using the same math. Days 31 to 60 are for building investable cases. Translate your reliability opportunities into the language of risk retirement and EBITDA. Ensure your assumptions are validated by finance, so the cases are ready for serious ranking and funding. In the final month, launch your governance. Establish the monthly value reviews and the quarterly board risk dashboards. Assign owners to the risk register and define exactly how decisions like run to failure or shut down are made. Looking further out, a 12-month roadmap moves you from establishing visibility to creating an enterprise standard. It's a journey from understanding value to scaling a mature reliability capability across the entire organization. Ultimately, we want to build a finance-friendly reliability culture. This means changing the questions we ask. We should reward defect elimination and risk retirement just as much as we reward safety and production volume. To maintain this, every board should ask 5 simple but difficult questions. What asset risks could stop our business plan? What value do we retire this quarter? And where should our next dollar be invested to maximize return? Our final takeaway is this: reliability is not just a department. It is a financial control system for your physical assets. When reliability speaks finance, maintenance decisions become enterprise decisions that protect cash, retire risk, and create lasting value. As we wrap up, I want to disclose that the visuals and frameworks in this deck were created specifically for this educational synthesis to provide a cinematic and clear industrial narrative without proprietary data. Please note that this presentation is for strategic and educational purposes. All financial calculations are illustrative and must be validated against your own site-specific data and engineering standards before being used for business decisions. Finally, for those who wish to dive deeper, we have included a list of selected references from SMRP, Rockwell, Deloitte, and McKinsey. These sources provide the industry context that supports the frameworks we've discussed today. Thank you for your time.